Hello and welcome to Problem 10 in my Calculus 3 or Multivariable Calculus problem solving series. In this video, we're going to use tangent planes to approximate the value of a surface at a point.
So this question asks us to find the linear approximation of f of x comma y at 2 comma 1 and use it to approximate the function at this point. So f of x comma y is z equals x squared plus y squared plus 3. And it has this shape here, and we want to find the tangent plane and use that to approximate the value of the function at this point. So the first thing we're going to do is to rewrite this as a form of a level surface. So making a new equation, a new function that is a level surface to find the gradient so we can find the tangent plane. So once we have our level surface, we need to take the gradient. And to take the gradient, we need to take the partial derivative. So the partial derivative of x with respect to x is 2x. With respect to y is 2y. And with respect to z is -1. So that means that the gradient is equal to 2x comma 2y comma -1. And the gradient at the point of interest, which we're looking at, is going to be 4 comma 2 comma -1. So this is going to be our normal vector for our plane. So now we have the normal vector, which is 4 comma 2 comma -1, and we can use it to find the plane. And remember that the equation for the plane is a times x minus x0 plus b times y minus y0 plus c times z minus c0 equals 0, where a, b, and c are the components of the normal vector, and x0, y0, and z0 are our point on the plane. So it's going to be x0, y0, and z0 is going to be 2, 1, 8. And a, b, and c is 4, 2, and -1. So let's go ahead and plug everything in. So we see that a is 4, and then it's x minus 2. And then b is 2 times y minus 1. And then we see c is -1 times z minus 8. And that's going to be equal to 0. And then let's distribute and simplify. We get 4x minus 8 plus 2y minus 2 minus z plus 8 equals 0. And then we're going to move all the constants over to the other side. So the equation for a tangent plane is 4x plus 2y minus z is equal, so we'll move the 8. So this 8 and this 8 cancel out, and we're just left with 2. And this is going to be our equation for the tangent plane. So let's go ahead and use the equation of the tangent plane to approximate the value of the surface at this point, 2.003, 0.997. So we're going to plug in the numbers for x and y, and we're going to solve for z. And when we do so, we find that z is equal to 8.006. So this is approximately what the surface, or the equation of the surface, will give you when you're at this point. We can also compare this value to the actual value of the function of the surface at that point. So let's go ahead and plug in the point to find the actual value of the surface at 2.003, 0.997. So the function f of x comma y is 3 plus x squared plus y squared, and we're going to plug in this point, and we're going to swap it out for x and y. So we have 3 plus 2.003 squared plus 0.997 squared. And when you put it into the calculator, or you calculate it, you get 8.006018. So compare that with our value or approximation with the tangent plane, we see that there's a very small difference of only 0.000018. So this is the difference between the actual value of the surface and the value of our approximation with the tangent plane.
That's all for now. Thanks for watching.